Good morning. In this video lesson, we're going to continue to focus on what we started with yesterday. How do we determine the number of solutions to an equation? As we discussed yesterday, last week, and in 7th grade, all the equations we solved seem to always have exactly one solution. But yesterday, and today especially, we're going to focus on some equations don't have exactly one solution. As you look at our first objective for today, we need to understand not every linear equation has exactly one solution. As we started to see yesterday, some of our equations will actually have no solutions, and some of them are going to have even infinite solutions or a never-ending number of solutions that all work in the equation. Some examples here when we see e.g., again, that means, for example, if we had an equation x plus 1 equals x plus 2, there isn't any value in the world, plus 1, that has the same value as when you add 2 to that x. So that's an example of an equation that has no solutions, and here again we see an example of an equation that would have infinite solutions. We're going to talk more about those as well. These key terms should be familiar to you by now, but again, pause the video, take a look at this if you're not familiar with what some of these key terms mean. Okay, let's take a look at the guided problems for today. Your first job, problem number 1, is going to be to determine the number of solutions to each equation below. And you're going to have two options. You could do that by inspection. That means really just figuring it out by looking at and thinking about the equation, maybe figuring out some answers in your head. Or inverse operations to gather and combine your like terms. That's kind of, as Mr. Neville said last year, peeling the onion, or the step-by-step process we worked on last week. So go ahead, pause this video, and for the red equation, green equation, and purple equation, try to figure out the number of solutions. And if you do that out on a whiteboard, insert images of your work. If you figure it out by inspection, you're just going to write a quick explanation instead of inserting an image of your work. As you're working that out and the video's paused, I'm switching to my whiteboard. And now you're coming back. Hopefully you figured some of this out on your own. We'll talk you through what I see. First equation we're going to look at is the red equation here. The red equation says r plus 8 is equal to 5 plus r, and we see that here on the whiteboard. If you solve this by inspection, if you just start to think about this equation, I'm going to put it into full screen for a second. R is really 1r, and on the other side of the equation, that's also positive 1r. So we've got the same variable with the same coefficient, but on the left side, we're going to add 8 to that number, whatever it is, and on the right side, we're only going to add 5 to that number. Because of this, no matter what we do, the left side is always going to be 3 bigger than the right side. If I make r into 2, let's try that. 2 plus 8 equals 5 plus 2. That's not going to work in the equation. This side, 10, is 3 bigger than 7 because of course it is. We added 8 here and we only added 5, 3 less to the r on this side. So it doesn't matter which number we pick for r, there's nothing in the world that could work for an equation like this. We have no solutions here. I'm going to try to solve this by inverse operations now, but you at this point should have what you need to have written an explanation. There's no solution to this equation. We can tell that just by inspection. But if we did this out with inverse operations, we see that the r, the variable term, is on two sides, the left side and the right side. We would have to gather those with inverse operations. I could subtract r from one side of the equation. R minus r would be gone. I would have to subtract r from the other side, and what we'd see on both sides of the equation, because the variable had the same coefficient, when we tried to gather the variable, it canceled out or eliminated on both sides. All that we're left with in this equation is 8 equals 5. I know 8 equals 5 is a false statement. This is them trying to tell me there is no solution that works for the equation. No matter what I plug in for r, this side, 8, is always going to be 3 bigger than this side, 5. So when we try to solve an equation and we see the variables disappear as we try to gather them, one possibility, if it's left with a false statement, means no solutions. The next one we're going to take a look at, so either you're going to insert an image there or put an explanation, the green equation and the purple equation. Take a look at the green equation here. 2g minus 4 is equal to negative 4 plus 2g. How many solutions are we going to get for an equation like that? If I solve by inspection, if I look on both sides of the equation, the variable term is a positive 2g. And on both sides of the equation, the constant term is a negative 4. So here it doesn't matter what I pick for g, it's always going to get multiplied by 2, and then it's going to get subtracted by 4. I could say the left expression and the right expression are equivalent at this point. They both have a positive 2g, they both have a negative 4. So when that happens, it doesn't matter what I pick. If I pick 3 for g, 2 times 3 minus 4 equals negative 4 plus 2 times 3. That's going to work because 6 minus 4 is the same exact thing as negative 4 plus 6. They're both going to give us positive 2. I could make x equal to 5, and then would just be getting 2 times 5 on both sides, so we'd get negative 4 plus 10 on the right side, and 10 minus 4 on the left side. Both of those would add up to make 6 equals 6. Again, a true statement. Every number I pick for g is going to work in this equation because the left side and the right side are identical or equivalent expressions. This has an infinite number of solutions. The symbol for infinity right below that, you can say infinite solutions, or if you can find this symbol on your computer, go ahead and call an infinite number of solutions for the green equation. The last equation we're going to take a look at, I'm running out of time on the video, sorry for this, is the purple equation. 4p plus 5 equals 2p plus 5. Here we're going to notice the variable terms on opposite sides of the equation do not have the same coefficient. This is not going to be an example of no solutions or infinite solutions. When I try to gather these variable terms, the p's eliminate on one side but not the other. 2p plus 5 equals 5. At that point, we have one variable term and two constant terms. The constants are not gathered yet. Since the variable's on the left, we should move this positive 5 over there. We accomplish that by subtracting 5 on both sides. That eliminates. That eliminates. Don't be fooled here. 2p is equal, what is 5 minus 5? To 0. This does not mean no solutions. My variable terms didn't disappear from both sides. It's just that 2p is set equal to 0. What number times by 2 equals 0? I know that p has to be equal to 0 here. So this equation, the purple equation, actually has one solution at the end of the day, and this image of the whiteboard shows you why p could be equal to 0. 0 plus 5 is equal to 0 plus 5. So if p is 0, that does work in this equation. That doesn't mean there's no solutions. It means there's one solution. At this point, you have what you need. You should be moving past the guided problems. I would recommend skipping the challenge problems today for now, and I would go straight into the practice problems. But in the limited time I have on the video, I'm going to try to show you one of the optional challenge problems, but I'm going to get cut off by time, I think, here on the 10-minute limit. So if you have 3m minus 4 minus 5m equals negative 3 minus 2m plus 7, you should be pausing this video, trying to figure that out on your own. How many solutions will this equation have? So hopefully you figure this out on your own. You should see there are 3 variable terms, 2 on the left expression, 1 in the right expression, and there are also 3 constant terms, a negative 4 and negative 3, a positive 7. I'm going to combine the like terms that are already gathered. The m's on the left side. 3m minus 5m is negative 2m. Negative 3 plus 7 gives us a positive 4 minus 2m. Now I see the variable term on both sides is identical, but the constants are actually not identical. So I could add 2m to both sides. I know that's going to eliminate on both sides. Negative 4 does not equal positive 4. What is the equation trying to tell me? There are no solutions, because at the end of the day, this equation is just going to take something and subtract 4 on the left side. It'll take the same thing, add 4 on the right side. There's no value for m that could ever make an equation like that work. Some of you should have even recognized there were no no solutions. As soon as we got to that row, the rest of this was actually unnecessary. Looks like I still have a little time left. I'll try to show you the fuchsia pink one. So again, if you paused the video and did that last challenge problem, you should be doing this on your own. But if you did it on your own, we have 1/3 times 12f minus 15 plus 3f equals 5 minus f. For that, you should see the first thing I need to do is distribute. 1/3 times 12f is just like doing 12 times 1 divided by 3. Timesing by 1 does nothing. So really, I know 1/3 times